Today I'm gonna show you some programming technique for input devices in Linux, and also event handling and signaling in Linux as well. So I made some program and I divided by three tasks. These are the three tasks that I'm going to show you. And let's look at the first one, set jump and long jump. Um, These are descriptions of set jump and long jump. I suggest you look into it. And then in this program, I set it the mouse button, and then when I double click the right side of mouse button, it's gonna execution computation will be terminated, and then exceeding results I put out. So I'm gonna show you what that is. So let's look at the first task. Um, but before you do anything, you have to know where your uh, mouse device is. So you want to put ls input, which shows you all the devices, input devices. This is the power, the keyboard, and this is virtual mouse, and you have the generic real mouse here, so you know which device you want to. And then you want to have your program and then run makefile. Then it will show you the makefile. The task 1 was created here. Then I'm gonna put sudo always to avoid the permission error. Then I'm gonna do task 1, and then I'm gonna have to choose the device, the input device actually. So in our case, it was event 3 was our mouse. So let's do this. So let's terminate everything so that it can initialize. So mouse initialize here, and then set up the long jump was used. No double click yet, and it shows the time. And you can end this by Control C anytime you want. But I accidentally clicked left click here. Let me click the left, left. So it's all left. Then I'm gonna click right, left, right. So when I click right button twice, but it was slowly clicked. So when when the time between the clicks are not enough, it's gonna show you it's slow mouse click. So what's it gonna do when I click double click? So here you can see that when the mouse double click, um, it shows you the time and signal was generated, and then double click detected and calculates the time or so, and the signal sent. So it basically shows you that set jump and long jump is working uh, at the same time that mouse, you know, double click is showing the time and terminates the execution. So let's move on to the second one, the signal handling in Linux. So here are some task description, so you can pause and read it. And so here what we're going to look at is what Linux signal facility does, and what is the time the signal handler associated to the thread gets executed in the following cases. So A, B, C, D, those following cases we're going to look at the time, and then we're going to see the result by trace command and then kernel shock. So for second task, I'm just gonna go over quickly through all four cases, And the first case, I'm just gonna run and then show you the result. So here's the first case. Here you can see that there is a current time, and then each time there's operation that's going on, and which operation is going until the execution is completed. So it just shows you all the results. So it's gonna. The second one also will show you the thread is runnable. Um, when the thread is runnable, how it is it operating. It just shows you also the current time and the operations. So if you like to maybe see the details of the time and then what's going on, you can also do trace command as I explained before. Um, maybe you can type different ways. There are many ways to see these results, but I like to do it this way. And then you'll also see the result here, but not only here. Um, you'll see you'll be getting the trace.dat file, and then you'll be able to see the corner chart file as well. So execution completed. I'm gonna put Control C to terminate, and then I'm gonna do corner chart trace.dat. Mine obviously showed a little failed, but let's see. Here is the kernel shark that you can run. Shows you every times and then what kind of operations you have been doing in each time, in each event, what kind of events occur. So it shows you the details. So let's do the next one. So the next one is thread is blocked by SL4. Then you can also see the result, but in this case thread, since there are multiple threads, you will see different results, which thread is it working on. So you will see some kind of context switching here. So for the last one, also shows you the current time and the operations. So here are the tasks too. So now let's take a look at task 3. It's the signal delivery to all threads. So here are some descriptions. So you can take a look. So the question was, is above statement correct for SIGIO? So for the task 3, I still need to do some more work, but I will show you just it's developing the multiple threads, and then see which see if all threads are registered to receive the signal and be ready for it. Let's look at it and then see the result here. I still need to develop some more. I'll play around with it. Here I still need to choose the right input device because I use the mouse thread here as well. Okay. So you can see that there are 7 threads that was initialized here successfully, and every thread number 620 is being sleeped and success. And so here you can see that thread number 5 completed thread job pending, signal is waiting here, and then this renewal 5 completed, 2 completed, and so on, 4, 3, 6, 1. It's not in order, but you can see that the thread job is completed all in a row, and then also shows you the time. So basically that's it. I hope you enjoyed my video. Uh, if you have any questions, please email me. I will answer your questions as best as I can. Thank you.